Consider a strange run of years. A brutal heat dome bakes the Pacific Northwest of America, shattering temperature records by margins that no one had ever thought possible. A sudden, savage freeze plunges deep down into Texas, collapsing its entire power grid. Catastrophic, unrelenting floods drown fully a third of the nation of Pakistan. And relentless droughts crack the earth dry across 3 separate continents at once. At first glance, these disasters seem utterly, completely unconnected. Scorching heat here, bitter cold there, floods in one place, drought in another. But a steadily growing number of scientists have come to believe that many of these catastrophes may, in fact, share a single, hidden, common cause. Because high above our heads, a great and invisible river of wind, one that steers the weather for fully half of the planet, may be changing. Slowing down, beginning to waver, and getting stuck. It is called the jet stream, and if these scientists are right, then its transformation could help explain why the weather absolutely everywhere seems to have suddenly become so wild. And so strangely stubborn, all at the very same time. Before we go any further, if this is exactly the kind of story you came here for, take just 1 second to subscribe. A lot of folks watch these all the way to the end and simply forget to, and it genuinely helps this channel keep making them. Alright, let's begin. So first of all, what exactly is the jet stream? High up in the atmosphere, somewhere between about 5 and 9 miles above your head, which is, not coincidentally, right around the same altitude at which the big passenger jets fly, there flows a band of ferociously fast-moving wind, howling from the west to the east, sometimes at speeds well over 100 miles an hour. This is the polar jet stream. And it is very far from being a mere curiosity for airline pilots. It is, in fact, one of the single most important features of our entire global weather system. Because it acts as a great atmospheric boundary, a kind of fence, if you like, that separates the cold, dense, heavy air of the Arctic, lying to its north, from the warmer, gentler air of the mid-latitudes, lying to its south. And, most crucially of all, it is the jet stream that actually steers our weather. That great, endless parade of storms and warm fronts and cold snaps that marches its way across entire continents like North America and Europe is, in large part, being shepherded and guided along its path by this one high-altitude river of wind. In a very real sense, when the jet stream is passing overhead, then so too is your weather. In fact, the jet stream shapes daily life in ways that most people never even notice. Airlines, for instance, know it intimately. A passenger flight traveling eastward, from New York to London, say, will deliberately try to ride the jet stream like a great tailwind, getting a powerful free push that can shave an hour or more off the journey and save an enormous amount of fuel. A flight going the other way, westward, against the wind, has to fight it and takes noticeably longer. The jet stream is also a major source of the sudden turbulence that can rattle an aircraft, and over the long term. It is the jet stream that governs the rhythm of the seasons across much of the world, steering the rains that farmers depend on, and setting the pattern of warmth and cold that shapes what can grow, and where. This single ribbon of wind is quietly woven through almost everything about the weather we live in. And here is the truly crucial part, the thing that actually drives the jet stream in the first place. Because at its very heart, the jet stream is powered by a temperature difference. Specifically, it is powered by the sheer, enormous contrast in temperature between the frigid, frozen Arctic and the warm, humid tropics. You see, because our planet is heated so unevenly by the sun, baked relentlessly at the equator, and left frozen at the poles, the atmosphere is engaged in a constant, restless struggle to move heat energy from the hot places toward the cold ones. And that great temperature gradient running between the pole and the equator, combined with the steady spin of the Earth itself, is precisely what powers the jet stream and sets its tremendous speed. And this hands us a simple, but a genuinely powerful, rule of thumb, one that is the key to this entire story. The bigger the temperature difference between the pole and the tropics, the stronger and the straighter and the faster the jet stream will flow. And I'm genuinely curious as we go, before today, had you ever really thought about the jet stream or known what it actually does? Let me know down in the comments. I read them all, and honestly, they often decide what I dig into next. So now, here is where the problem comes in. Because one of the very clearest and most utterly undeniable signals of climate change to be found anywhere on planet Earth is this: the Arctic is warming far, far faster than the rest of the planet. By some measures, it is heating up somewhere between 3 and 4 times faster than the global average. Scientists call this phenomenon Arctic amplification, and it is genuinely beyond dispute. The Arctic is warming at a breathtaking, headlong rate, and its once permanent sea ice is vanishing before our eyes. Now think back for a moment to our simple rule of thumb. The jet stream, remember, is powered by the temperature difference between the Arctic and the tropics. But if the Arctic is now warming so much faster than the tropics are, then that all-important temperature difference is inevitably beginning to shrink. The cold end of the whole equation is quietly getting warmer, and a smaller temperature difference must mean, by the very same logic, a weaker engine driving the jet stream. And this is precisely where a compelling and a genuinely worrying scientific hypothesis enters the picture, an idea that has been championed by a number of prominent climate scientists over the past decade or so. And the idea goes something like this: as that crucial temperature difference shrinks and the great engine of the jet stream weakens, the jet stream itself begins to slow down. And a slower jet stream, these scientists argue, behaves in a fundamentally different way from a fast one. A fast, powerful, energetic jet stream tends to flow in a relatively tight and fairly straight line, wrapping neatly around the globe. But a slow, weak, sluggish jet stream begins instead to meander. It starts to wander and to buckle, developing enormous, lazy, sweeping loops that bulge far to the north and then dip far to the south, very much like a great river slowing down as it crosses a flat plain, and beginning to snake into ever wider and looser bends. And you can picture the result rather like a garden hose left running on the ground, wriggling and whipping from side to side. Each big southward kink of the jet stream, plunging down toward the equator, tends to be balanced out by a big northward bulge somewhere else. Which means that, at the very same moment, one whole region of the world can be bulging up into unusual warmth, while its neighbor is being plunged down into unusual cold. Quick one before we continue. If someone in your family or a friend would find this genuinely fascinating, please do send it their way. That word of mouth is honestly how a channel like this one grows. And if it's been worth your time so far, a quick like really does help the next person find it too. But here's the thing. The waviness of the jet stream is only actually one half of the problem. Because the truly, genuinely dangerous part is what those big, slow, lumbering waves then go on to do. They get stuck. A fast, straight jet stream keeps all the weather moving briskly and healthily along. A hot day, and then a cooler one, and then a spell of rain, all in a steady, orderly rotation. But when the jet stream buckles up into those big, slow, sweeping loops, those loops can stall out completely, locking a single, solitary weather pattern firmly in place, right over one unfortunate region, for days or even for weeks on end. And this, right here, is the key that unlocks absolutely everything. Because nearly all of the most devastating weather disasters are not, in truth, really about how intense any single day happens to be. They are about persistence. They are about the very same weather stubbornly, relentlessly refusing to move on and clear out. And a stuck jet stream is a machine for manufacturing exactly that kind of stubborn, persistent, deadly weather. Take the heat dome. When one of those great northward loops of the jet stream stalls out and gets stuck, it traps a vast dome of high pressure and hot air sitting right underneath it, and that superheated air then simply sits there, baking the very same region day after day after day. That is a heat dome, and it is the exact mechanism behind the brutal, punishing heat waves that have hammered Europe in recent summers, and behind the record-shattering heat that famously cooked the Pacific Northwest. Now take the deep freeze. When one of those great southward kinks of the jet stream instead stalls and gets stuck, it does the precise opposite. It carves out a long channel that allows frigid, brutal Arctic air to come plunging deep, deep down into regions that are utterly, completely unprepared to deal with it. This is how you get those savage, shocking cold snaps that occasionally freeze the American Deep South, like the catastrophic freeze of 2021, which plunged all the way down into Texas and collapsed its power grid in a state that had simply never planned or built for such a thing. Then take the Great Flood. When a wet, rain-bearing, low-pressure system gets trapped and held in place by a stuck jet stream, it can proceed to dump weeks' worth of rain onto the very same patch of ground, again and again and again, which is the exact recipe for the kind of catastrophic biblical flooding that submerged vast swaths of Pakistan. And finally, take the drought. When a dry, high-pressure system gets stuck fast over a region, it can block virtually all rain from reaching that area for weeks, or even for months at a time, slowly baking and drying the land to dust, and driving the kind of severe, punishing droughts that have gripped parts of so many continents. So do you see the pattern now? Heat and cold and flood and drought, four utterly, completely different kinds of disaster. And yet, if this hypothesis is correct, then all four of them can flow from the very same single root cause, a weakened, wavy, and stuck jet stream, holding wild and extreme weather locked in place for far, far too long. It is, in a certain sense, a kind of grand unified theory of stuck, extreme weather. And there is one particular moment from recent history that captures this idea almost perfectly. Back in the summer of 2010, two enormous disasters unfolded at the very same time, on opposite sides of the same continent. In Russia, a monstrous heatwave settled in and refused to leave, baking the country for weeks, igniting vast wildfires, and killing tens of thousands of people. And at almost exactly the same moment, just to the south, Pakistan was struck by some of the most catastrophic flooding in its entire history, as relentless monsoon rains poured down and submerged a fifth of the whole country. For a long time, these looked like two separate tragedies. But scientists studying the atmosphere found that they were, in fact, deeply linked, two sides of the very same locked, stationary, buckled jet stream pattern. The same stuck wave that trapped the scorching heat over Russia was also helping to funnel and hold the drenching rains in place over Pakistan. One frozen kink in the wind, two catastrophes, thousands of miles apart. And there is an even deeper and rather stranger layer to this idea, which some scientists have proposed for the summer months in particular. It is a phenomenon with the rather technical name of wave resonance. The theory suggests that when the jet stream weakens in summer, it can sometimes actually split into two separate ribbons of wind, one branch veering off to the north, and the other to the south, which then act together to trap weather systems in the still, stagnant zone caught in between them. When this happens, the big waves in the jet stream can lock into place and reinforce themselves, growing larger and more stubborn in a kind of self-amplifying feedback. And this particular mechanism has been suggested as a driver behind some of the most extreme summer events on record, including that deadly 2003 European heatwave and the Pakistan floods and searing heat in Texas. It is another way for the atmosphere to get itself dangerously and persistently stuck now at this point. You have very likely also heard another particular term thrown around a great deal, especially during those brutal winter cold snaps, the polar vortex, and it is genuinely worth taking a moment to clear it up, because the two things are constantly, endlessly confused with one another. The polar vortex is actually a separate thing entirely, and it sits much higher up, way above the jet stream, in the layer of the atmosphere called the stratosphere. It is a great spinning ring of bitterly cold air that whirls around the North Pole each and every winter, and which normally helps to lock all of that Arctic cold safely in place up in the far north. But the two are, nonetheless, closely related. Because sometimes the polar vortex itself becomes disrupted, it can weaken, or stretch out of shape, or even split apart entirely in a dramatic event that scientists call a sudden stratospheric warming. And when that happens, it tends to distort and disturb the jet stream down below it, making the jet even wavier than before, and helping to shove all of that trapped Arctic cold air spilling southward. So the two of them can work together, hand in hand, a disrupted vortex high up in the stratosphere and a buckled, wavy jet stream down below it, combining together to unleash those truly brutal and memorable winter freezes. And it is worth pausing to really understand why this quality of stuckness is so uniquely dangerous to us. Because almost the entire fabric of human civilization is quietly built upon a single, hidden assumption that the weather moves on. Our bodies can endure a hot afternoon because we trust that the cool of the evening is coming. Our power grids are built to handle a normal range of demand, not weeks of unrelenting, record-breaking extremes all at once. Our farms are planted for the usual rhythm of rain and sun and gentle variation. Our reservoirs, our roads, our homes, all of them are designed around the ordinary, comforting expectation that no single kind of weather ever lasts for too long. A stuck jet stream shatters exactly that assumption. It removes the reprieve. It takes a hot day, or a wet day, or a dry day, something we could easily shrug off in isolation, and it holds it, and holds it, and holds it, until the heat becomes a deadly wave, the rain becomes a flood, and the dry spell becomes a devastating drought. It is not the extremity of any single day that breaks us. It is the refusal of that day to ever end. So, is all of this actually settled? Is the jet stream definitely, provably breaking and definitely causing all of these disasters? And here, I have to be completely and scrupulously honest with you, because this happens to be one of the single most genuinely debated and contested questions in all of climate science right at this very moment. Let me start with the case in favor, because its foundations are genuinely rock solid. The core building blocks of the idea are simply beyond any dispute. The Arctic really is warming several times faster than the rest of the planet. That part is carefully measured, and it is absolutely certain. The jet stream really is driven by that temperature difference between the pole and the tropics that is settled physics. And a stuck blocking jet stream really does cause persistent, devastating, extreme weather. That, too, is basic, uncontested, textbook meteorology. Not one of those individual pieces is seriously in question by anyone. But here is the catch. The single most crucial link in the entire chain, the specific claim that Arctic warming is actually, measurably, causing the jet stream to become wavier and more stuck, and thereby driving more of these disasters, that one specific link remains genuinely contested and as yet unproven, and the scientific disagreement over it is very real and very sharp. Some studies have indeed found a strong signal connecting the two, but a great many other studies have found only a weak one, or a murky one, or in some cases no reliable connection at all. And the climate models themselves flatly disagree with one another. Some of them do produce a slower, wavier jet stream in response to a warming Arctic, while others produce almost no change whatsoever. And a few of them even suggest that the jet stream could actually end up getting faster and stronger instead. Some scientists point out, quite reasonably, that the amount of atmospheric blocking, those stuck patterns, has not actually clearly increased over recent decades, even as the Arctic sea ice has so dramatically melted away. And that is something you really would rather expect to see if the theory were straightforwardly and simply true. And then there is the ever-present scientific trap of confusing correlation with causation. The mere fact that wild weather and a warming Arctic happen to be occurring at the same moment in history does not, all by itself, actually prove that the one is truly causing the other. The honest truth of the matter is that this is alive and an unsettled and a genuinely fascinating scientific frontier. It is entirely possible that Arctic warming really is subtly loading the dice toward more stuck and persistent weather in ways that are real but that are simply very hard to cleanly measure against the vast natural chaos and noise of the atmosphere. But it is also entirely possible that other factors are the main drivers of all this wild weather, and that the specific jet stream connection is a good deal weaker than its strongest proponents believe it to be. Good, careful, honest scientists genuinely disagree with one another on this, and the great question remains very much open. So let me end, as I always try to, with genuine honesty and with real balance. What we know for absolute certain is already sobering enough entirely on its own. The weather all around the world does genuinely seem to be growing more extreme and more stubborn, the heat waves longer and fiercer, the downpours heavier and more sudden, the dry spells deeper and more punishing. And high above all of our heads, the great invisible river of wind that has faithfully steered our weather for the whole of human history is now flowing over an Arctic that is transforming and warming faster than anywhere else on the entire planet. Whether or not that is truly bending the jet stream out of its familiar shape, whether the jet stream is, in the end, genuinely breaking, is a question that the world's scientists are still, at this very moment, working extremely hard to answer. But what is really not in any doubt at all is the deeper point that sits underneath the whole debate. And it is this, that we are, all of us together, running a single, vast, uncontrolled experiment upon the one and only atmosphere that we have. And that the intricate machinery which quietly governs our weather is far more delicately balanced and far more deeply interconnected than we ever really fully appreciated. The jet stream is completely invisible. Almost none of us ever stop to think about it, even for a moment. And yet it may well be one of the single most important threads holding the entire familiar fabric of our weather together. And so perhaps the real question of our age comes down to something as simple and as unsettling as this. What exactly happens to all of us down here on the ground if that one invisible thread should ever truly begin to fray?